Hey guys, I'm Jade. Today is my LeetCode review vlog on 105th problem. Construct binary tree from preorder and inorder traversal. We are given two integers array, preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree. We have to construct and return the root node of the binary tree. Let's examine one here to understand this problem easily. We got input binary tree and the preorder is 3, 9, 20, 15, and 7. And the inorder is 9, 3, 15, 20, and 7. And we should return the root node of this binary tree. Then, let's get started with the intuition to solve the problem. And the keyword is recursive approach with hash map. If we wanna construct a binary tree from its preorder and inorder array, we have to understand the properties and features of these different kind of traversals. For the preorder traversal, the first element of the preorder array is always the root node of the tree, and all the elements of the left subtree are behind the root node. Furthermore, the elements of the right subtree are behind all the elements of the left subtree. Next, for the inorder traversal, the elements to the left of the root node is the inorder array represent the left subtree, and the elements to the right represents the right subtree. So we can use these features and properties to recursively construct the binary tree by identifying the root node from the preorder array. And then we have to split the inorder array into two subarrays, and also the preorder array into two subarrays. Then we can recursively build its left subtree and right subtree. Next, let's get started with the code and annotations to solve the problem. The very first step, we have to create a member private map of integer and integer, a member field, a member variable. Let's call it inorder map. Inorder map. We'll create the inorder map to store the indices of elements in the inorder array, which can help us improve the performance of finding the root node, the index of the root node in the inorder array. And then inside the build tree method, we have to initialize the inorder array. Inorder map equals new hash map. Next, we have to fill the hash map with the mapping rules from the elements in the inorder array to their indices. So we can create a for loop. Let's say int I equals 0, and I should be left than inorder array dot length, and increment I after each iteration. Inside for loop, we have to put new entries into the inorder map. Inorder map dot put the value of inorder of I and indices and index of it. And out of the for loop, we have to create a helper method and call it with 6 parameters. Let's say we can create the helper method first, private, and let's call it, the return type is tree node because we have to return the root node of the binary tree. Let's call it build tree helper. And there are six input parameters. The top three parameters are int array, preorder, pointer, and the indices of the start and end, which is int pre-start, int pre-end. And the last three parameters are the in-order pointer and its start and end indices. In order int, let's call it in start and int in end. And we have to recursively call the build tree help method to help us build the binary tree. So here we have to return the return value from the method, from the build tree helper method. Build tree helper method with 6 parameters. Here is preorder and its start and end indices, which is 0, and preorder dot length -1, and then comes to in order 0, in order dot length -1. And inside the build tree helper method, first we have to take care of the edge cases. If there are no elements to construct the tree, we just return null. If restart is bigger than pre-end, or in start is bigger than in end, which means there's no more left node to build the tree, so we just return null. Next, we have to create a new node, and the first element in the preorder array is a root node. So we can create a new tree node with value of the pre-node of pre-start. Tree node of root node equals new tree node of preorder. Preorder of the index of pre-start. This is because the first element in the preorder array is the current root node. And we also know that nodes of the left subtree and right subtree come after it. Next, we have to find the index of the root in the in-order array using a hash map. And the code is int in root index equals in order map dot get root value. Then we also have to get the number of elements in the left subtree, because with this information, then we can split the left subtree and right subtree from the preorder and in order array. And is left tree size equals in root index minus in start. Here, as we go to here, we have already know the index of the root in the in-order array and number of elements in the left subtree. So we can split the in-order subarray and pre-order subarray into smaller left and right subtrees. And then we have to recursively construct the left subtree and the right subtree. First, let's construct the left subtree recursively. So the code is root.left equals build tree helper method with another new 6 parameters. First is preorder and its new start and end indices. The start is pre-start plus 1 and pre-start plus left tree size, and the later and the last 3 parameters are in order pointer and its new start and end indices, which is in start and in root index -1. Next, we also have to recursively construct the right subtree with new 6 parameters. The code is root.right equals build tree helper, because we have to reuse the method to do the recursive operation. And the new 6 input parameters are preorder and pre-start plus left tree size n plus 1, and the end index is pre-end, and the last 3 input parameters are in order pointer and in root index plus 1, and the final in end. And then we have to return the root here, return the root node. And that's all the code for this approach. Let's submit code to check for the correctness and analyze the time and space complexity. Yes, our code got accepted. And the time complexity of this problem is big O of n. This is because every node in the preorder array is only checked for only one time. And we also try to find the root index in the inorder array, and it takes big O of one time due to the hash map. So the overall time complexity, it is big O of n, and the space complexity is big O of n2, as we create an extra hash map to store the indices of every node in the inorder array. And we also use some spaces for the recursion stack to build this binary tree. And this is the end of my LeetCode review vlog on this problem. Construct binary tree from preorder and inorder traversal. And I highly recommend you guys to visit my online GitHub repository here. And yes, I'll put my new notes for this problem later. And you can also visit my GitHub repository here, which contains all the codes and notes to build this online GitHub page, which contains the problem description, intuition, Java code with annotations, and the final time and space complexity analysis. And I'll put those 2 links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.